In this lesson, you'll learn how to solve quadratic equations by factoring and write a quadratic equation with given roots. How is a zero product property used in geometry? The length of a rectangle is 5 inches more than its width, and the area of the rectangle is 24 square inches. To find the dimensions of the rectangle, you need to solve the equation x times x plus 5 equals 24, or x squared plus 5x equals 24. This is a quick one, so let's go ahead and solve it. I need factors of negative 24. That'll give me a sum of positive 5. So my two factors, if I multiply this out, x times x is x squared minus 3x plus 8x gives us 5x minus 24. I can solve those two related mini equations and I find the two values to make this true, or if x equals negative 8, which probably isn't going to work out so well for the side of a rectangle, or x equals 3. In the last lesson, you learned to solve a quadratic equation like the one above by graphing, not the most efficient method. Another way to solve this equation is by factoring. Consider the following products. Anything times 0 always equals 0. Notice that in each case, at least one of the factors is 0. These examples illustrate the zero product property. For any real numbers a and b, if a times b equals 0, then either a equals 0, b equals 0, or both a and b are equal to 0. So if you have x plus 5 times x minus 7, then x plus 5 equals 0, and or x minus 7 equals 0. It kind of worked out well in this one. We had to throw out one of our solutions, there's our and or, because it didn't make sense in the real world situation. The first step to solve by factoring is to move everything to one side of the equation. And then this time our greatest common factor is all we can factor out. So our two mini equations that we have to solve are x equals 0, which is solved, or x plus 4 equals 0. Hopefully in Algebra 2 you can subtract 4 from both sides in your head. So I don't make you show that, but I am, so you know where it came from. And we're done. And as always, it's a good idea to check by substituting back into the original equation. So 0 squared equals negative 4 times 0. Yup. And negative 4 times negative 4 is 16 equals negative 4 times negative 4. The first thing we need to do to solve this next one is to put everything on one side of the equation. I move to the left, so my x squared term would be positive. Then we are looking for factors of negative 6 that are going to give us a sum of negative 5. So positive 1 and negative 6 will do the trick. So we have 3x squared minus 6x plus 1x minus 2 equals 0. And notice negative 5 is the same as negative 6 plus 1. And greatest common factor for the first two terms is 3x. So I have x minus 2. And I'm just going to take out a 1 there, and I have x minus 2 again. So my two factors are 3x plus 1 and x minus 2. And when we set each of those factors equal to 0, we find our two solutions are negative 1/3 and 2. And again, we should substitute back into the original equation to check. I'll let you guys do that on the calculator. Again, our first step is to put everything on one side of the equation. And if I were you, when you're copying it down from the book, I would just start with writing it that way. Then we need factors of 9 to give us a sum of negative 6. Negative 3 and negative 3 does the trick. And so I get x equals 3 twice. We don't need to write it twice. Once is sufficient. Example 2 printed in your book had the two roots being x minus 8. So they had x minus 8 times x minus 8. So now you can see why 8, or in our case 3, is called a double root of the equation. It's used twice. And once again, GeoGebra is a handy-dandy tool that you have for free download on any device now, pretty much. And you can see that the only place it touches the x-axis is at x equals 3. This is a really smart way to word a multiple choice question for solve by factoring. They said, what is the positive solution? So they didn't give you both solutions. That's kind of smart, because then you could just plug and chug and see what works. I'm going to divide both sides by 2 first, just to make my number smaller. And now I need factors of negative 21 that give me a sum of negative 4. So negative 7 and positive 3 work. So my two roots are 7 and negative 3. The question asks for the positive root, so our answer is going to be 7. Write a quadratic equation with negative 2/3 and 6 as roots. Write the equation in the form ax squared plus bx plus c equals 0, where a, b, and c are integers. So we're going to plug into our x minus one of the roots, so minus negative is going to be a plus, times x minus the other root. Now, I'm not crazy about the fraction, so I'm going to multiply both sides by 3 right off the bat. So I have 3x plus 2 times x minus 6. And now I can FOIL without fractions. So I have 3x squared minus 18x plus 2x minus 12 equals 0. Combining like terms, the only like terms I have are the x's, so negative 18 plus 2 is negative 16x minus 12 equals 0. I thought this would be a good opportunity to show you how to use that as feature in your table. So I put this in the table. After I hit enter, I switched it to ask instead of auto. And then I typed in the two values we were interested in, negative 2/3 and 6, and wouldn't you know, they both gave us zeros. You could have also used Algebra to look for the zeros, but I thought that would be fun to look at what your calculator will do. Zero product property for any real numbers, a and b. If a times b equals 0, then either a equals b 0, b equals 0, or they both equal 0.